Okay, so while we're trying to solve the problems of batteries and resistance and sprockets and everything on our quad project, I want to introduce you to my other autonomous vehicle. So this is the semi-autonomous vehicle currently known as Fred. Why he's called Fred? No real reason. When we were building it several years ago, I asked one of my students to throw out a name for it, and somebody yelled Fred, trying to be the smart ass, and Fred it was. So right now, Fred is a little bit disabled. He had a failure. The speed controller failed. I think I have it fixed. I'll explain that in a second. This is its latest configuration. Okay, so there's been several different looks. This is the most kind of industrial, modern look that I'm trying to go for. Trying to make it kind of steampunk looking, but that remains to be seen. So let me just take you quickly through the technology here, because the covers are all loose and everything. So under here is let me just put this down. Oh, sorry. Underneath here is the control panel for it. So just kind of quickly through the control panel. This is the speed controller. This is what's powering the tracks. Actually, let me take the next lid off as well. And I'm just going to put this down. So now this is the kind of insides of it. This is heavy power down here. So power coming in from these two batteries at the back. So a couple of reasonably deep cycle kind of batteries. I think my other vehicle is going to probably end up getting 4 of these, is my guess. But I want to talk to the battery experts and get their opinion on it. A couple of wheelchair motors. So these are out of a these are out of a full electric wheelchair. Bought off eBay. Up here is the speed controller that runs those motors. So it takes this battery power from the remote control radio. The receiver for the radio is here. This is talking to the speed controller, and that makes it into a tank style steering. So that's just kind of what it needs to make it go forward. To add other control to this, again, I want this to be somewhat autonomous. I've added this, what they call a Pixhawk controller. This is a flight controller from a drone or from an airplane. It has a rover mode, which is what we're doing. So rover is kind of a ground-based vehicle. So I'm using this in rover mode, and it is talking to the speed controller to control the tracks. It has a telemetry system. This is all busted up. The case is broken off here, but this, through a 2.4 gigahertz, I believe, signal, can talk back to a ground station and put information, longitude, latitude, all that kind of stuff. This is just the control, or the terminal board I built. So the 15 pins from the speed controller. They are all I have 12 of them here on here. That's all I could, the terminal strip underneath only had 12. So I'm not using 3 of them, but it's not a big deal. I'm using like, I don't know, 5 or 6 of them probably is all I'm using. But it gives me lots of room to expand. This is a telemetry unit for the remote control radio. This sends radio signal information, how strong the signal is. This sends it back to the radio, and I can, on the front of my radio, I can see battery voltage, not distance. That would be battery voltage. Strength of the radio signal primarily is what you want. I had it, so I put it in. This is just a anything to anything kind of voltage converter. So there's a potentiometer on here. So voltage coming in, you can turn this potentiometer and get back out again. That's how I'm getting my 5 volts for a lot of this stuff. A lot of these devices here needed 5 volts for things. So this is taking 12. Let me show you where that comes from. Underneath here are a couple of buck converters. So the system's at 24. One of these goes from 24 to 12. The other one goes from 12 to heavy current 5. And then the 12 comes up and it goes to this, which is, I'm using for light current 5 volts. So I think this is probably cleaner power than that is under there. I don't know for sure, but my guess is this is clear. Because I need it for things like the Raspberry Pi. This is a full-on computer, right? This thing is, if you're not familiar with them, you can plug in monitors, you can plug in USB connections, Ethernet, you get Wi-Fi modules for it, you put SD cards in it. It has its own operating system, one of these things. So this was going to do the computing for the autonomous part of it. Right now, the Pixhawk is controlling not completely autonomous. You could it'll run a mission, right? I can draw a picture on a map, send it out around the park all by itself. But if there's children in the way, they get run over. So there's nothing. I could put some sensors into this. There's places I could put sensors in. This has got serial connections, so I can have other computers talk to this. I can have this talk to this using computer code. So it's pretty advanced. Um, I'm not really thrilled with the interface of this. It's not bad. There's some decent stuff online for it. Lots of forums, people using it. It's very popular in the RC, airplane, and quad hobbies. Not as big in the rover stuff, but it's the best. It's reasonably cheap. I think it was $150 or something. Over here is the compass for it. So this is picking up GPS antenna and a compass. So it knows which heading it's on, and it knows where it is in the world because it's picking up longitude, latitude, sending it back to this thing. And then this thing is taking that and saying, okay, the route that Tim picked is the next leg of it is at this heading. I'm here at this location now. I want to be at that location. I have to drive that direction for this long to get there. So that's the kind of the technology for the autopilot right here. This, I think I'm going to change this out. I don't know enough about Raspberry Pis yet. One of my challenges was to learn. That's one of the things that this rebuild was going to give me is a chance to learn this technology. But since then, I've learned about something else called a Jetson Nano, and this is very new to me. This new nanotechnology or Jetson nanotechnology. It's very similar to this, but it's like this on steroids. It has much more computing power. It's meant for the AI field. I want this to be more artificial intelligence than just mission planning. I want this to kind of learn about its surroundings. I want to learn about its world. I want it to follow me to the grocery store with a wave of my hand. Or I want to talk to it and say, follow me or go home. And I want this thing to understand those commands. So the Jetson Nano has that kind of control. It has voice recognition, object recognition, all that kind of stuff. I want to learn about that level of technology. Up here we have a couple of voltage meters. So there's three voltages on this, 24, 12, and 5. And when the key's turned on, these light up and tell you what the voltage is. It also tells me whether the fuse is blown, because these are powered after the fuse. There's a couple fuses in here. So if the fuse blows, this voltage reads 0. And now it can tell me whether the fuse is blown. Headlights off of track lighting, found some LED bulbs, machined some adapters, put them in. I've been spending some time polishing it. It's filthy right now, but when it's polished up, it looks pretty good. There's still some scratches. I want to polish them out still. Rebuilt these side plates. This had 3D printed plastic bushings, so the shaft from the motors comes out through here. It comes out at this point right here. And then there's a chain that drives the back, and now it drives the sprocket. So this was in a plastic bushing, and from the grit getting in there, it was eating up away at the end of the shaft. So I put bearings in here. I 3D printed a bracket for a bearing, and then put this brass plate over top, and now I got to polish all this up and make it look very pretty. Working our way around to the back. Whoops, sorry. These are off of an airplane. I got them from the school, from the aircraft. They were having a garage sale, so I got real airplane tail lights. These are very cool. They've been outfitted for LED. There's LED bulbs in them, but I think the lights are very cool. They're aluminum. They're very, very cool devices. So this is Fred. I'm going to be doing a little bit of work on it. The speed controller blew up on this one too, so I think I have it fixed. I have to reinstall it, reconnect it all. And then once that's done, this thing is ready to go again. Not sure what to do with it. I would love to kind of combine this one and the other one. Maybe build a trailer for behind the quad that pulls this, and they can talk to each other. Maybe one can follow the other one. That's technology down the road. But I'm kind of proud of this. I think it's very pretty. I have all kinds of plans for things I can make it do. It's not the most stable. I wish the tracks were longer. This is the narrowest I can make it for the length of the track. So it's actually almost wider than it is long, which makes it it steers quickly. It steers really well. It has lots of control, but it's very tippy. We had a trailer on it once. We put a towing ball on here, and we've had different attachments that we had for the back of it. And every time it would stop, just the inertia of this the towing ball would tip it forward off of its tracks. So It's not really good for towing or anything, but I'm thinking maybe a set of forks for the front that could automatically go pick something up, autonomously. You have the Jetson Nano find the object, and then use the stereo cameras to line it up, and then maybe laser beams to keep it aligned and know when to lift it. I don't know. This is what we think about when we're doing this kind of stuff. So this is my other project. I'm going to spend some time on it, get it back together again, and maybe when it's done, I'll give you guys a tour of how it works. It works pretty well.